Good afternoon, everyone, and welcome to another session of Introduction to Neural Network. I hope I'm audible and I am having cold, so maybe you can have issues with my pronunciation. So please let me know if you have any issue in that. I'll be sharing my screen. Before that, I'll just share today's session. So okay. Oh yeah, it's a. So I have sent the collab link for today's session, and I'm sharing my screen. Yeah. So I hope the screen is visible. Someone can confirm if I'm audible and my screen is visible, please. So in today's session, we will be dealing with neural network from scratch. There are so many libraries in machine learning like TensorFlow and PyTorch, which directly uses this neural network function where all the functions, that all the hidden layers, input layers, output layers, all the mathematical computation that needed to be done is already there. Over here in today's lecture, I'll be dealing how we can build a neural network from scratch using just one library, that is Numpy. Okay, why Numpy? Because there are a lot of mathematical computation and all of that can be done just using Numpy. Okay, I'm hoping all of you would be knowing the basic theory of neural network. So, not taking that time, I'll be telling about neural network, what neural network is. So, neural network concept actually came from how our brain works. Okay, so like how our brain is connected to each and every part of body using a very small unit of our human body, that is called neuron. Similarly, neural network has been taken from that concept, and each neuron is connected to all the neural network, which collectively called as neural network. Okay, so in this we have input layer, we have output layer, and in between the layers are called hidden layers. Why hidden layers? It's basically where the all mathematical computation happens. So if I can say like the machine learning is nothing, or a neural network is nothing. It's just a, consider it as a black box where you're putting it as, you're giving some input. In that black box some mathematical computation is happening, and then you're getting your desired output. Okay, what that mathematical computation is happening, that is what our concern is, and how we can improve that computation so that we can get the desired output how we need it. Okay, now moving ahead, there's something called perceptron. So perceptron is nothing but a mathematical model which is when combined gives a layer of neural network. Okay, so these x1 x2, these all are called inputs. These w1 w2 are called weights. What are these weights? These are used, these are the one, you can say, criteria which decides our output results. Okay, and weights and biases which are combined together, and this is called activation function. Okay, so activation function, what is the use of activation function? What is an activation function? We will deal with it. So what is the benefit of using neural network? I would like to quote a very basic example. So think about like now day to day life, think about a washing machine. So in washing machine we put certain clothes, we want our output which we know that is a clean cloth, right? In between there's something happening in the washing machine, that is what that black box is doing. And that input and output is what our neural network is doing. What is the advantage? Like, we can always go back. What does it mean? For example, we needed clean clothes from our washing machine. What if we don't get it? We can again put it into washing machine and we can again ask it for cleaning, right? That is what it is called, feedback. Okay, and that is what one property we have in our neural network, that is forward feed and backward propagation. Will come later. Before that, what is the use of, like, what is this activation function? Okay, and what is the use of this activation function and why this non-linear term is there? So again, I would like to take again the same example, the washing machine example. So agreed, we have our cloth as an input, our washing machine is doing some function and we are getting output as clean cloth. But we are putting detergents as an external thing to, enhance our result, to get like more clean clothes, right? That detergent over here is the activation function in our neural network. So activation function, it helps to like deal with more complex factors between the neurons. Okay, why non-linear? Because a linear function will make no sense. Why it will not make sense? Just imagine if we have y is equals to mx plus c. That is a linear function equation, straight line equation. So over here, my x and y are dependent, right? If x increases, y increases, x decreases. So there will be no different changes, right? So there should be some effect, right? It's nothing like we're giving dirty clothes. We need dirty clothes itself. We need clean clothes. So there should be some transition. So that is why non-linear activation function has been used. Okay. So there are so many different activation functions. So some are these tanh, ReLU, sigmoid, linear. There's so many different activation function, and you can use any activation function according to your need. Among all, the most commonly used is ReLU activation function. Okay, in this example also we'll be using with ReLU activation. Okay, so why do we have weights and biases? Okay, so weights and biases actually deals, or it helps to deal with how we want our output. It can help in adjusting with we can always come back, we can always update our weights and biases so that we can get the desired output. As seen, weights are describing the strength of the connection between neurons. Okay, bias can shift the activation function. Thus, the neuron needs a lower or higher value of fire. Over here, fire term has been used for the activation function mostly. Okay, so now training process. So there are two processes for this. One is feed forward and one is back propagation. I told you, right? So feed forward is nothing which it's more of like okay, if we're talking about washing machine example, just putting clothes, putting detergent, it will be doing something and giving the output. That is feed forward. Okay, so it's more of like we are providing data to the neural network. It goes through all the layer, all the activation function is being done, all the calculation is being done, matrix multiplication and everything is done in feed forward, and my output is giving. But from here the things comes into picture. What if we are not satisfied with our result? Satisfied with this, we don't get the desired output. Then we go with the back propagation. It's more of like we again go back and check where the issue was. What was less? What can be improved? So that is what back propagation is. In this, in machine learning or in neural network, we do the back propagation by updating the weights and biases values. How we do is, this is something called chain rule. Okay, so we'll go back, we'll see what are the weights values that has been provided, and either we can increase it or decrease it. But we have to make sure that the cost function should be less. We cannot keep it doing again and again and again. That is not a good way to run your neural network. So ideal way, how we are going to know what weight and what bias should be. Firstly, yes, it's a hit and trial method. Secondly, there is a way which one thing we know is my cost function or my loss should be minimum. In ideal cases, it should be 0, and it cannot be 0. That is why it is ideal condition. What we can do is we can minimize the error over the time. Okay, so how we can do is there's something called gradient descent. So if we look at this picture, in this, if we have started from this point, the starting point, there's something called iteration. Iteration, you can think it as a steps. Okay, so we have the different steps. With each step we are trying to reduce my value. What value? That is weight or biases value. We are checking at what value it is giving. And this terminology, there is something called learning rate. So I'll again give you one example. For example, there are so many steps. You are in a building, and over there are so many steps. At one step there is some clue which you need to find it. Okay, that is what we consider it as convergence or my final value. That is what you need to find. So what you will do, you will be going each and every step, right, to see at which step that clue is. You cannot skip any step, you cannot increase any step, right? So this is what it is called learning rate. Learning rate is also chosen by a hit and trial method. So learning rate is like, it should not be very high, that is you cannot take 2 steps at a time, or it should not be very small, that you should not take half step in one step stair, right? It will take so much of time. So it should be again taken in something in between, 1 step at a time. Similarly, there is iteration. So every one thing you will be doing, either you will be going down, or you when you're going down, you see, okay, the loss is not decreasing. Then again you will start going up. The loss is decreasing or not decreasing. That is called iteration after every iteration. So this is what we deal with. This is called gradient descent, by which we found the convergence point, or we can say the point where my loss is minimum. Okay. For this, I have taken this hyperparameters. Hyperparameters is something which we defined, okay, which we can change over the time. So there are different layers, layer 1, layer 2, nodes. Batch size is something, okay, again I'll take the example of washing machine. So just imagine if you have 100 of clothes, you cannot put all your clothes in washing machine at a time, right? There is no use of that. It will not work. So what you do is you divide it into batches. Like first 10 clothes you will put it, then 10 clothes. Similarly for the our neural network, we define batch size. So over here batch size I've given is 64. Learning rate 0.005. This all things can be, change over the time. You can adjust it according to your need or results if you're not getting the desired result. And there is something called epoch. Okay. So the data set which I've considered over here is, I've already deal with this data set, that is called MNIST data set. It's a data set which is having 60,000 training samples and 10,000 10 samples. It's a very huge data set, and it consists of 0 to 9 different handwriting digits. Okay, so we are going to work our neural network, build our neural network on this. Okay, we are going to train our neural network on this. First step is to prepare the data. So from now onwards, whatever I'm going to do is I'll be defining a function, and then I'm doing it. What is the benefit of that? At least I'll be knowing whenever I need to make changes, my function is already needed. I don't need to, again make any changes in entire code. Just in the function, if I'm making any changes, wherever it has been called, that changes will already be implemented. Why it is required now? Because now when we are going to deal with our code, it's a huge compile of code. Okay. Yeah. So, yeah. Okay. So first function which I have defined is by path, where I will be defining my data. So data I have given as xtrain and ytrain, the training MNIST data, and xtest and ytest as MNIST test data. Okay. Then I have divided that one hot encoded data. One hot encoded data is like 0 to 9. I'm giving it as the numbers 0, 1, 2, 3, 4. The numbers has been given. Then I'm normalizing my function. Like, why there's a need of normalizing it? Because my this pixel values, because this 0, 1 to numbers is nothing but an image, right? And each image is represented by a 28 cross 28 pixels, and each of them contain values which ranges from 0 to 255. So it's a grayscale value, but I don't need this range of grayscale value, so I need to normalize it. I need to keep it between 0 to 1. So that is why I'm dividing it by 255. So I'll be getting a normalized value. Over here, what I'm doing is data is equals to np.gen. So my data, that is .csv file, will be, it's not in the form of a column or matrices, but we need it in that form for the computation. It will mostly in the form of like 1, 2, 3, 4 or 5, 6, something, just a comma. So that comma thing is called delimiter. So I am telling that take those data from the path which I have defined, and it will be in the delimiter form, and get me in the form of this, how the data is defined over here in the output. Okay, I'm returning my normalized data and my one hot encoded data. Okay, one hot encoded means, for example, if a user will put a 8-digit data, the output will be 8. Okay, that is one hot. It's more of like a cat or dog picture. If I'm giving a picture and I'm asking if it is a cat or not. So if it is a cat, give it as 1. If it is not a cat, give it as a 0. So something like this. Okay. Now I'm building my neural network. So I've created a class neural network, and in this class of neural network, all these like functions that has been created is there. Okay. Now I'll see each functions step by step. First thing is to initialize my neural network. So how to initialize? I'm giving the size of my batch, my learning rate. See, batch 64, learning rate 5e minus 3. So that 0.0005 learning rate can be written as 5e minus 3 as well. Epochs, everything. I'm defining my input as x, target my y. I'm reshaping it, batch size, epochs, learning rate, everything. Okay. Okay. So these are my weights. The weight sizes are there. Weight W1, W2, W3, B1, B2, B3. Weights and biases are there, and I'm giving my activation function. If I'll go back, I'll show you. If I'll go back, so this is my layers, right? So I have defined 2 layers, layer 1 and layer 2. So for layer 1 I have given 256, layer 2 I have given 128 node values. So this is what I'm writing over here. So W1 I have given it as my input, which is 256, W2 is my 128, and this 10 is after the calculation of that, and similarly the biases are there for B1, B2 and B3. The activation function which I have taken is ReLU. So I am calling ReLU self.x, and this np.maximum0x is from ReLU function itself. My ReLU function have something called max0x. So this max0x is what I have written in the coding function. Okay. Yeah. So okay, my activation function is done. I have defined some other activation function as well. That is, one is derivative of ReLU, which will come when backpropagation is going to take place, and softmax. Softmax is something, instead of just giving a hardcore results like 0 is cat or not cat, 1 is cat or not cat, something like this, there is chances when I'll give 2 pictures together. For example, I'm giving a cat picture also, I'm giving a dog picture also. Now in the output, the result will be like 0.7 and 0.3. So 0.7 defines, for example, if my dog, and 0.3 cat. This means since 0.7 is the higher value, that means it's a dog picture. Okay. So that is what in the terms of probability also, like, this is the maximum probability, then this will be the output. So that is where softmax comes into picture in our output results. Okay. Now the feed forwards comes. So if we'll go back to the equations of feed forward, so we'll see. So for the one layer, Z1 is equals to W. If L is my layer, and if I'm talking about first layer, so I'll be like Z1 is equals to W1. Z1 is my layer 1, my first activation layer. W is my weight 1. A1 is defined as my ReLU function for first layer. So see, ReLU function will always be for previous layer, A, L minus 1. Like the previous layers ReLU functions is being done, plus BL like bias. Okay, so exactly like this, Z is equals to W into A plus B, where A is my ReLU function. I'll be writing it in code. It's nothing much, it's just writing it in a code. So if you see weight 1, np.random.rand, that's just creating a random numbers, self.input.shape 1 comma 256. So it's similar to that. Like I'm initializing my first this neural network, which I have given it as Z1. So Z1 is equals to self.x.dot. So this is just like matrix multiplication we do. So that is why we are giving dot self.w1. Okay, w1 plus self.b1. So the equation was like this, right? Z1 is equals to my w1 into a, where a1 was my ReLU function, plus self b1. So this is what I have done. Similarly, I have just written it into coding language, nothing else. And I have done the assertion where I need to know what are the outputs there. In other two, like A1 and A2, I have given ReLU, while the output, A3 is my output, right? So A3 I have given softmax, because I need my result in probability terms. Okay. And error, how do you calculate the error? Similarly, like predicted, A3 was my output, so output minus my true output. Okay, so A3 was my predicted output, Y is my true output. So this will give me my error. So this error should be minimum. Okay. Now what if my results is not coming good? So we'll go to the back propagation step. So in back propagation step, if we'll go back, it's again the same equation, which I have not mentioned, I guess. Okay, so back propagation, if we'll go to the equation, it's more of like a like since whatever calculation we are doing, to go for the back propagation, we have to do the derivatives, and those derivatives are chain rule derivatives. For example, if you have to do the derivation of log x square, you cannot just directly do the log x square. You will first do the derivative of log square, that will be 1 by x square, and then again the derivative of x square, right? So this is called the chain rule of derivation. Similarly, in back propagation also there will be a chain rule. So this is how we are going to calculate the derivative of all the three weights and the derivative of all the three biases. I would request you, when you will see this Python programming, write all the equation in front of you and then see all these codings. You will relate it, okay, where it is and how it is. Okay, and then I'll give in the assertion where I'm defining the shape of all the derivatives of weights and biases. But this is not it. Okay, we have calculated, okay, this should be the weight now, this should be the ton. Now I need to tell the model what are my updated weights. For the updated weights, there's formula called, if my updated weights are W, then it is called as W is equals to W, which is the previous weight, minus learning rate into the calculated updated weight. Okay, so this is how my updated weight is calculated. So this is what I have done over here is W3, W2, W1 with the updated weights, and LR is my learning rate. Similarly, for the biases, I have done the same. Okay, now all this function has been done, which is where I have started was initializing my neural network. I was giving batch size, all my learning rate and nodes values. Then I was started with the feed forward, and then I started with my back propagation, and then what I need to do is now train the function. So how we are going to train the functions? We are going to tell what are the start points. So if you'll see over here, I have created a definition train function where I have given the start function for the batch. So my batch, what is the start, what is the end? Why end is batch plus 1? Because I need it, if it will start from 0, it ends at 50, not at 49. Okay, and I'm giving it at feed forward, back propagation. I'm calculating the error. So error, for every batch there will be some error, so I'm finding the mean of all the errors. I'm counting the accuracy of like there are just two things which needed to be calculated, which is one is loss. So loss should be as low as it should be, and accuracy, if loss is less, accuracy is more. So how you see a network is working or not, its loss should be reducing. Okay. Okay. So this is my loss appending, this is my accuracy appending which I'm calculating. Over here my training of function is done, everything is done, loss has been calculated, accuracy has been calculated, my neural network has been updated. Okay, now I need to see the results. In terms of result in neural network, we can see the results by loss and accuracy. Loss should be decreasing with every epoch. Similarly, accuracy is increasing or not, that is a different story. If loss is reducing, this at least this means that my neural network is training correctly. Accuracy, there could be accuracy depends on so many other factors. Okay, so most important thing we need to say is loss is reducing or not. So let's see if I have created again plot for loss and accuracy plot. So if when I done this, I like run my cell, I can see my loss and epoch, like graph between loss and epoch, which epoch we can see my loss is reducing. If you can see with 20 epoch my loss was around what, around 0.020, but with 50 epoch it's reduced to 0.015. So obviously my loss has reduced, right? We can see accuracy is 87.9%. It's pretty much good accuracy. Obviously its accuracy can be increased, its accuracy can increase 10 times more than this. There's so many factors that depends on this, like my learning rate, the nodes which I've considered. I've just considered 2 layers. You can increase the layers, you can decrease the learning rate, you can increase the learning rate, you can decrease the batch size, you can increase the, so overall that hyperparameter I showed, you can modify those parameters anytime. Similarly, the learning, the activation function which I have considered is ReLU. You can take it as sigmoid, tanh. You can just work on it and see how it works. Okay, what are the results you are getting, what kind of results you are getting, and how things are working. So this lecture was mostly to know what is actually happening in neural network, how you can create a neural network, you can build a neural network. Okay.
Ma'am, weight and bias would be trial and error, given by trial and error method, or we have to predetermine it.
It's a trial and error method. It's definitely, it's more of like, for example, initially you put a weight for, just an example, you put a weight and biases of 2 or 3, okay, respectively, but you're not getting the result. You will come back, you will again check either by decreasing or either by increasing. I'll come into that thing. I was just about to come. That is called, that is what it is called, cost function. Cost function is function which should be very less. Why it is less? Because you cannot infinitely keep increasing or decreasing your weight. That will affect your cost function. Cost function is nothing but, for example, I'll tell you about in washing machine example. When you wanted a clean cloth, you're not getting a clean cloth, you'll come again and again and again, right? But what it is costing you is your electricity, right? Your electricity will be costing. Similarly over here, where we cannot again and again and again keep doing it, there should be some midway thing. So this is what it is called as gradient descent. We come up with a gradient descent. Gradient descent, learning rate, these are the ways by which we update our weights and biases, by which we tell, okay, this is the way you have to take the weight, or this is, so there's something called cost function. Cost function is where your error is minimum, or your, see, if we talk about this graph, okay, so this is the best example I can give you. This is a starting point. For example, the first weight and biases you give is this point. What you see is your weight and biases, your result is not coming good. You'll go back again, you will either decrease it or either increase it. Okay, so our main aim is this, the convergence. You can see the convergence arrow. This is what we our aim is. We want our loss function to be minimum or cost function to be minimum. So the ideal case is 0, which is like the ideal case. That is why it is ideal case. That cannot happen. Always there will be some error, but what our thing is to minimize the error to the maximum. Okay, so gradient state descent is just like a step. You either take a step down, either take a step up. Okay, so how we do is we do it by step. This step by step is called iteration. Okay, we give certain iteration like 10 iteration. We assume, okay, in 10 iteration, either by decreasing or increasing, my weight will be updated, and that will give the maximum result. Okay, that is
Ma'am,
yeah.
hello.
Yeah, please go ahead.
Ma'am, if you are uh, considering the washing machine example as a batch size, so what if the some data are too much complicated? Then what? Then how can we should we using the same neural for the complicated data, or we should change it for complicated data?
Obviously
Like
we
if we consider a washing machine, then
yeah.
uh, considering a washing machine example for the chunk of clothes, some clothes are too much dirty, some clothes are little bit dirty. Then
Yeah,
we have to adjust our data, adjust our powder or RPM as per the requirement. So then
exactly.
we have to change our neurons in our neural network.
Exactly. What you have mentioned is to the point. It's very accurate. Actually, we have, this is the, that is what it is. There's a word called scratch, neural network from scratch. It's very basic. When you will go ahead with neural network, there are so many other terminologies will come into pictures. There's something called dropout layers. This dropout layers are like, there are certain ways by which we can even drop our certain nodes. Okay, so what I meant is, these neurons are there, right? So these are now fully connected neurons. There are half connected neurons as well. There can be that just because of this one neuron, your whole network is not giving good results, so you have to drop this neuron. There's method for that also. There's something called deep neural network. Deep terminology means, as you increase the number of neurons or number of layers, that started to call as deep. There's so many ways, there's so many different neural network itself, different architecture of neural network. What I am telling is the very basic one which you can deal with. So right now what I'm telling you is the what a neural network behave is, what a neural network is. There's so many. You must have heard about convolution neural network, you must have heard about recurrent neural network. So what you're talking about is, obviously, with coming demand of what we need to, and what kind of data we need to deal with, what kind of complexity we need to deal it, our whole entire neural network changes, our whole entire, it's working changes, everything changes. So everything depend on what is our requirement, and that is what we deal with. Till now, whatever I have worked with, either logistic, linear, SVM, or even EDA, whatever classes I have taken, the important thing which I have mentioned it, anything can be modified according to our need. So obviously what you're saying is, that is needed, otherwise your model will not work, your neural network will not work. Okay, so okay, so data.
Okay, ma'am. And
Yeah,
hello.
please go ahead.
One other thing, ma'am. If we want to select some particular clothes, means only dirty clothes,
Yeah,
then how can we do? Means we want only a best suited data,
yeah,
best selection of
yeah,
data.
yeah.
Then how can we deal with that?
We can deal with it. There's something called feature extraction. Okay, there's something in neural network itself, there's something called feature extraction. So for feature extraction itself, there are different methods. um, uh, if one very commonly used is SIFT. Okay, scalar invariant feature, I forgot. Okay, so SIFT, there's something called like this. If you just search the methods for feature extraction, you will get it. So what does this do is, when we, before our neural network, we can put this feature extraction thing, where it can, what particular kind of features you want, it can extract that, and then it can start working on it. Okay, so what you are saying is similar to that. Okay, so it might sound you a bit complex, or it might be like you're not able to understand, but trust me, if you'll go back, you'll see the equation of back propagation. What I will suggest you is keep the equation of back propagation in your hand, keep the equation of updated weights in your hand, and just then see the codes. You will understand what we are talking about here. It's nothing but the equations has been converted into code. That's it. Okay.
Ma'am, what active function could be used in backpropagation?
We have, like, see, uh, since we have used ReLU as activation function, we are using ReLU as in back propagation itself. But if there are so many other activation function, you can use it. Okay, ReLU is one activation function which is most widely used. Okay.
Ma'am, like in the activation function, there was one sigmoid function that was extending into the third quadrant.
Yeah.
Uh,
Yeah.
so I was thinking that maybe it would be better to use that function since we are back propagation is all about learning from what the result is
See,
generated.
that's what I'm saying. There's no hard and fast rule that you have to use ReLU itself or you have to use sigmoid itself. How you are going to work with your neural network and by what way your neural network is giving a good better result is what we have to look. Okay, so it's
And and we also need to reduce the complexity of it. We do not want it
exactly, exactly,
complex.
exactly. So that's what that cost computation should be low as well. So you have to keep so many things in your mind before designing a neural network. So that is why most of the times what we do is we just use the TensorFlow. In that TensorFlow, we just need to give our learning parameters, the hyperparameters which I talked about. We can change those hyperparameters in our those TensorFlow and PyTorch libraries, and we don't need to take care of these things. Over here we are building our neural network from the scratch, like everything, the shape, the layers and everything. So yeah, you can like I have already shared this collab with you guys. You can anytime change your hyperparameters, you can change your activation function, you can increase your layers, you can whatever you want to modify and see how the results are coming, you can do it. Now we have to see, okay, what the accuracy is. So my accuracy is coming 87.9. I'm not saying it's a good result. It can be improved. It can improve 100 times better. Okay, that's not a question. What I wanted to show you is how you can build a neural network from scratch. That is what it is important, because building a neural network, because it is very easy, it is very easy to just call a function and change a hyperparameters and you can work on it. But what important is to see how your neural network is working, what is inside it, what are the functions that has been used. So this is what the neural network from scratch is. I would request, and this is very basic, with later on things I'll be increasing it, and I'll be letting you know how we can work with directly calling by just the functions itself. Right now I would suggest you guys to look into this cell, one long cell which I have created as class neural network. Each and every step, put all the functions, because neural network is nothing but a mathematical computation. Keep all your equations at one place and then look at these formulas and then look at this code, and I can assure you that you will be able to understand what we have deal with it here. Okay, so
Ma'am, this accuracy can be increased by changing the number of our step size means our n
exactly,
learning rate.
it can be increased by so many different ways. This hyperparameters I talked about over here, just changing the learning rate or just changing the number of epoch or just changing the batch size can also increase or decrease my accuracy. And this is one thing. Other than that, like how she told sigmoid, we can use a different activation function. We can like over here I have just updated my weight by one thing, right? You can update it once again. There's so many ways you can increase your accuracy. That's not the what I wanted to show you is how my neural network can be built. That is what concerned is. Okay, so I hope this session is will be useful for you for this thing, and please go with this. Please, I'll like request you to like work on this, and just look at what are the like equation lines I have written with the equations keeping with yourself. Other than you will not be able to understand it. Okay, I tried my best to like tell you what all like uh, this functions has been used, but it's not at all tricky. Okay, it looks complicated, but it's not at all tricky if you know how neural network works, if you know what are the equations of neural network. Okay, so yeah, if you have a question or anything, please let me know.
Ma'am,
Yeah,
please share your email ID.
I'll do that. Okay, so this is my email ID. I've already shared the collab thing. If you want, I can share it again. And yeah, I'll upload the videos as well. So yeah, uh, if there is no query, we can end the class. Okay. Okay, so thank you for today's class. We'll meet you in the next class.
Thank you so much, ma'am.